Welcome to TN Academy. For today's question, we are observing a drug that it is administered to an individual in milligrams, and the amount that's administered can be modeled by this question, where AT is equal to 500 e to the power of negative kt, where k is a positive constant and t is in time in hours after the initial dose is given. Now, for the first question A, we're asked to write down the amount of drug that would be found in the patient's body at t is equal to 0. So we can look at our equation to start off, which is the following, and we can see that e is raised to the power of negative kt, and we are evaluating for t is equal to 0. And so when t is equal to 0, negative kt will also equal 0, and e to the power of 0 is equal to 1. And so A, the amount in the patient's body at 0, at 0, would then be equal to 500. So there would be 500 milligrams of this drug in the patient's body when t is equal to 0. Now for question B, it says that after 3 hours, the amount of drug in the patient's body is decreased to 280 milligrams. Find the value of K. So we can write this statement here because what the question, the statement, the given values tell us is that A at T, which is 3, is equal to 280. So we can rewrite our equation to fully satisfy this and say that 280 is equal to 500 times E times negative K times 3. And we want to solve for negative K. So we can continue to rearrange our equation and divide both sides by 500 so that we just have the E to the power of 3K. And then if we take the ln of both sides, so that we can use the ln rules for a base E, and rearrange this power that the E has been raised to. We get ln of 280 over 500, and ln of E, which is just 1. I will be bringing the power down of 3K, ln of E, which is just 1. Then we can simply evaluate for K by taking the ln of 280 divided by 500 and further divide by negative 3. And if you evaluate this into your calculator, you should find that your answer rounded will come to 0.193. Okay, and that's your answer for question B. Now for our final part of the question, part C, the question states, the second dose, so a new dose, is given to our patient T hours after our initial dose, when the amount of drug in the patient's body is found to be 140 milligrams, and we're asked to find the value of T. So our statement here can be A at T is equal to 140. And now since we know our value of K, we can do a very similar rearrangement of our equation, instead to evaluate for T this time. So we will have 140 is equal to 500 multiplied by E to the power of negative K, which is 0.193, times the value that we are looking for, T. Okay? So if we again just rearrange our equation, divide both sides by 500, which is equal to E negative 0.193 T, we can then take the ln of both sides and bring down our power that the E has been raised to, of 140 divided by 500. And then we'll bring down the power. Here we get negative 0.193 t, and this is of course times the ln of E, which is simply 1. And so then if we want to isolate for t, we will divide both sides by negative 0.193, or k. Okay, so then you get ln of 140 divided by 500, which is again divided by negative 0.193. And if you substitute this into your calculator, you will get a lengthy answer of 6.58636, which we just round to be approximately 6.59 hours. Okay, and that is your answer for the value of t, the amount of time after the drug has been administered for it to have reached 140 milligrams.